Today we'll be talking about the Nomad 011 features. And we're going to be giving some demos. And some of those are going to be Autoscaling, CSI plugins, and some others will also pass by. So my name is Erik Veld, and I'm a developer advocate at HashiCorp. And the features that we will show today are Autoscaling, which I know is a feature that a lot of you have been waiting for, which is super exciting. So we can finally scale our jobs up and down dynamically, depending on the load or other real-time inputs into the system. Another feature that we'll be talking about is container storage interface. So this will let you dynamically create disks and then use those in your jobs. Task dependencies is another one that a lot of you have been asking about. So now we can actually have dependencies between tasks and even between jobs. And then remote execution in the UI. So you can actually, through the UI, exec into a running allocation. Then another feature that was announced in 0.11 is the audit logging, but that's only available in the enterprise feature. And I'll quickly go through that one before we'll jump right into the demos, which will be the biggest part of this presentation. So audit logging, what can you use it for? Well, it basically does what it says on the tin. So you can use it to meet compliance, create a paper trail of everything that's happening in your system. For instance, detect intrusions. You have people that shouldn't have access are actually accessing your system. And you can also use it to diagnose your cluster. So it's fairly easy to set up. You can add the audit stanza to your Nomad configuration, enable it, and then configure syncs where the audit logs will actually be sent to, for instance, to a file in the format of JSON. And then you can filter out events that you do not want to see. For instance, if they're very spammy or if you're not interested in it. And then what you'll end up getting is, in this case, since we wanted JSON format, we get the event stream in JSON, where we can see in which stage it happened, and then the details of the event. So that's a very nice feature for the enterprise users. Another feature, as said before, is autoscaling, which is very useful if you need to suddenly scale up your applications, like the number of tasks running. Say, for instance, it's Black Friday and you get a bit more visitors than you're used to. You can scale up, or you could scale down in case you want to reduce costs. Say, for instance, in the evening hours, your applications are not used, you can automatically scale down. Or just depending on the load, which is one of the use cases I will actually show in my demo. And it can also increase productivity, because normally if you want to scale up and scale down, you would have to change the numbers of the instances of your task group. And now that can all be done automatically. So I've created two demos for two of the features, and you can actually get them at this URL. I'll share them later, so you can actually run these demos locally on your machine as well, and you only need Docker. So let's head on over to VS Code. And actually, before I do that, I'm going to show you the setup. So I'm running these applications in Nomad. It's Nomad 0.11. I have a few jobs, and I'm already running the autoscaler on my cluster itself, and I have monitoring, which is Prometheus and Grafana. Now, all these applications are also registered in console, and I'm making use of the connect features in console. So all of the applications have a sidecar proxy that they will talk to each other through, right? So say, for instance, if we take a look at the actual architecture, we can see that web is calling API, and then the payment server is calling a Postgres database and a currency service to get the exchange rate. Now, web actually talks to localhost 9091. API talks to localhost 9091 as well, but on a different proxy. And then that one talks to two upstreams that are defined. So let's take a look at the code that actually defines this infrastructure. So I'm making use of a demo application called Fig Service, which actually gives us that UI that I just showed you and can show the trace. And the main important part of that is the service stanza, where we're actually defining that we have web, the port it's listening on, and that we want to make use of the sidecar proxies. So this will automatically start the Envoy proxy for us and inject it with our job. And I'm exposing metrics from these sidecars to Prometheus. And I'm using the docs.d format just because of the way this demo is set up, but you can actually expose those metrics directly to Prometheus. And I'm defining an upstream. So web, as we could see before in the call chain, talks to API. Then API talks to payments. And then from payments, we actually have two upstreams. So it calls the database and it calls the currency service. So if I actually go to the URL here, if I call this, we can actually see that these get called. And as you can see by the duration, it's actually updated with every call. So if we then take a look at Grafana, I don't have any load going through here right now. So let me actually put some load through there. So I'm now putting 35 concurrent clients in there, and they're going to be pinging the services continuously. So slowly, the instances are now coming in, right? So here we see the number of connections. And in Nomad, we can actually see that right now, we only have one instance of the API running. And as we can see, it sometimes gets hammered. Now, for demo purposes, these all have very low resource limits, but it's growing quite quickly. And the one instance has to take care of all of that load. Now, what we might want to do is, say, for instance, the API can only take 10 connections at a time or X amount that you've actually tested. We could actually scale up automatically to handle those connections and spread that over the instances. So as you can see, I was already running the autoscaler on Nomad itself. And here is the job that actually runs that. So I'm running a Docker container, and that is with the Tech Preview 2 version of the autoscaler. And the only thing that I'm doing is I'm running the agent and passing in a configuration. Now, this configuration has a few settings that are important. So first, we need to tell it where it can find the plugins, since it's a pluggable model for both the input and the output of the system. Then we need to tell it where we can actually find Nomad. So in this case, I've configured everything statically. So we can actually, let me actually do that so we have some more space, read the document or the configuration a bit more easily. So Nomad is located on the machine this application is running on the standard Nomad port. We can configure an APM plugin. Right now, we have only built the Prometheus plugin, but other developers could create their own. And we just have to tell it where it can find Prometheus, so it can actually pull Prometheus for metrics. And then there's a few strategies. In this case, we're going to use the target value, which will basically compare the current value with the desired value, and then try to figure out the factor of how much it should scale up or down, right? So I'm already running this. Then the second part that is important is that we actually use the scaling stanza in our job, right? So we can do this by adding the scaling stanza to our group. We can enable it. We can set a minimum and a maximum scaling value. So in this case, I want there to always be at least one instance of my API, and I want to scale up to a maximum of 3. I could increase this if I wanted to have it scale up more violently. For instance, if there's suddenly a lot of load, I could scale it up to 1,000, but at least there's a safeguard. And in this case, I've defined one policy that's based on Prometheus, and I've passed in a query. So if we take a look at this query, I'm actually using metrics from the Envoy sidecar proxy. So in this case, I'm taking the active connections for the local cluster of API. I'm taking out my local listener because I don't want it to actually count double. And I'm grabbing the average over time for 30 seconds. And I'm taking out all the values that would be 0, just to not skew the values. And then I'm using the target value strategy, and I'm saying that I want to have an even spread of 10 connections per instance on average. Okay, so if we apply this new job file, which I'll do inside VS Code. There we go. Let's run that, apply it. Then if we go back to Nomad, we can see that the new version is being applied, and the autoscaler has already detected the policy and is already scaling it up to 3, even though we didn't define that in the job. Now, if we take a look at the autoscaler, and we take a look at the logs, we can actually see that it's polling the values in here. And let's see, here you can see it trying to calculate a new count. And we can actually see that it wants to scale more to 4, but because we have a limit of 3, it's actually limited to that, right? So if we now take a look at Grafana, we can actually see that the average amount of connections is now spread over those instances. And the load is fairly even spread. I'm killing the connections as soon as a request is done. So it's a bit more volatile than it normally would be. And the load test actually dropped off, and it actually scaled back down to 1. So this way we can actually scale up and down our applications without our intervention. And if we take a look here to the API, we can see that it's now scaled all the way back down after it handled that load. Apparently the load is increasing again. And we can now see that Nomad is actually scaling up again. So that's a quick view of Nomad autoscaling. And I'll now hand it over to Jacquie, who will show you task dependencies. Jacquie? Or does Jacquie want me to do, or sorry, Jacquie will talk about CSI. Or does Jacquie actually want to let me do task dependencies?
Hey, sorry, can you just do task dependencies first?
Yes, no problem. I'll just move on with that then. Okay, let me share right back then. Skip over these slides and move back to task dependencies. So I'll talk about task dependencies then. So what would you use task dependencies for? Say, for instance, you have some startup scripts that need to run before your actual application. Or let's say your application depends on a total other application and you want to wait for that application to be running. Or say, for instance, you want to export logs to Loki or some web service that has your logs, or Elasticsearch. You could run a sidecar proxy or sidecar logging service next to that, right? So I'm going to show the first 2 use cases, one where we have a dependency on a other task to run before our job. And then I'm going to show you how we can actually have dependencies between jobs. So this is also located in the same demo directory. And I'll actually run it on the same infra that I just spun up. So if we take a look at our jobs, and if I kill one of the services, so in this case, oh, load test is still running. That probably doesn't help. If we take a look here, we actually have the payment service and the currency service. Now, what if I wanted to expose the currency service via the API as well, but I don't actually want to edit my API service to do that? What I can actually do is configure the service mesh to do that for me by using the L7 features, and I could create a service router that if I call the payment service with /currency, it would actually be routed to the currency service. Now, if we try to do that right now, we can actually see that we get routed from API to the payment service, and the payment service calls Postgres and it calls currency, but we're not ending up directly at the currency service. So say, for instance, I wanted to do that, and as soon as I launch my payment service, I want to configure that central configuration. Well, what I can then do is actually create a different task inside the group of payments, right? So this is inside the same payments job. I just add a task. And in this case, I'm adding the driver of Docker, but I could also have done an exec if I had the files locally on the machine, for instance. And in this case, I'm actually creating this script. So I'm creating a bash script where I'm writing the central config. So I'm writing the service defaults to set the protocol to HTTP, which I will need to do to make use of the L7 features. And then I'm creating a service router. So what this service router says is if I'm calling the payment service and I'm calling the /currency path, then instead route to the currency service instead of the payment service, right? And I've defined a lifecycle hook, and these can be of two kinds right now, but we're working on a third one. So it can be pre-start, post-start, and we're working on adding post-stop. So pre-start will be run before your actual task. Then post-start will be run after the task was run. And the post-stop will be after the task actually gets stopped. So in this case, I'm running it as a pre-start hook, which if you're used to Kubernetes, this would be comparable to like an init container, right? It gets run before the actual rest of the containers in the pod. And I'm actually making use of the console container, and then I'm just running that script that I just created, right? So it should write the service defaults and then create that service router. Now, I've actually already done this for the currency service as well. So that also has a pre-start hook defined that actually writes the service defaults. So that also has HTTP configured as the configuration, so I can make use of the L7 features. Now, if we apply this configuration, let me clear that. Write that. There we go. And if we take a look at Nomad, we now see that payments is being run again. And we can actually see the pre-start hook here, right? So it's actually downloading the console image right now. So the actual task is now waiting for that to complete. And exit code 0, which is good, which I think it's turned it out. here we can see, so it's actually moved on to starting the service. If I go back to payments, to config, we should see some logs that it actually wrote the, well, it doesn't want to do that, but it actually did it, and I can show you in the terminal. Name, payments. So we can see that we set the protocol to HTTP, and we can also take a look at the service router that we've created, which, if I make this a little bit bigger, we can see that this is the configuration that we had defined in our pre-start hook. So if we should now call /currency, we should end up at a different route. And I can actually do this in the UI so you can get a better view of this. So if we're calling any other path, we end up at the payment service. But if we call /currency, we can see that we now have a totally different path. And we did that by writing that configuration before we actually ran our task itself. Now you can use these init containers or pre-start hooks for many more things, maybe initializing a database or setting up some configuration for your application. It's a very nice use case for these hooks. But what if your application actually has dependencies on another application? Now to test that, I'm actually going to kill the database. And let's wait for that to actually stop. That's taking longer than I expected, but that's fine. In the meantime, let's take a look at the configuration. So the way you can do that is by defining basically the same configuration as we did before. But I now have a task, which I've called wait for database. Again, I'm using the Docker driver. And again, I'm using the pre-start hook. But in my actual configuration of my container, I'm now actually checking if the database is up. And in this case, I'm doing it simply by checking in console if the Postgres servers is already up and running. So in case NSLOOKUP doesn't return with it being up, we actually do a sleep of 2 seconds until it's actually up, and then we actually continue and run the payment service. Now let's see if the database decided to stop. No. Let's see if I can actually kill it through the terminal then. Purge database. There we go. Killed that one. Go to jobs. Okay, so we don't have a database now. The payment service is still running, but we're going to send in our new configuration now. So Nomad run, job dependency, and we can now see that it's being created. Now, if we go to the payments and we go to the allocation, it says running. But if we actually look here, we see that the actual payments task is still pending. And that's because the database is not there. So it's actually now looping in wait for database. And we can see that, okay, it cannot resolve the Postgres database. So what we can then do is if we actually run this again, we actually start the database again. We actually should see that the wait for database task exited. And now that the Postgres database is available, the payments service actually started. So we see here that Postgres is available in console again, and now the application actually works again. So now we actually call payments and it can call Postgres. So this can be very useful in case you have some services with some hard dependencies, and your services are not able to just restart and just recover when the dependent services become available. This actually allows you to code that dependencies into your jobs and wait for them to be healthy. And as I said, the NS lookup check that I have defined, you could actually ping a health check, you could do a dig on a lookup, you could basically put in whatever you want. You could even curl out to an external service like a SaaS and then check if things are available there. So with that, let's go back to CSI and see if Jacquie is now ready to do that. Thank you. How's it looking, Jacquie? Is the setup working?
There we go. I lost Zoom, so I was like, where did you go? So I got the second version working, and we're hoping that this will go. It's from a clean state now. Yeah.
Okay, I'm going to give you last thumbs up. Good luck.
Thank you. Let's see. I'll share my screen. So just to get started, my name is Jacquie Grindrod. I'm a developer advocate at HashiCorp, and previously I worked as a DevOps practitioner implementing things like Kubernetes and pipelines across different clouds. And now I'm working at HashiCorp. And we're going to talk about container storage interface, which was released with the 0.11 Nomad release. So before this came out, there was a few different options to run stateful workloads, such as a database in Nomad. If you didn't have too much data, you could do something like the ephemeral disk block to manage the job's data, or you could use Docker volumes or the host volume, which were features that we could use to mount a volume from the host into the container. But they couldn't be migrated between hosts, and they required that you managed your own orchestration around them. So we kind of wanted to build something a little bit better, which brings us to container storage interface. The CSI providers are third-party plugins that run as Nomad jobs, and they can mount volumes created by your cloud provider. So they're third-party managed. You can use anything that's built there. It allows you to build your own CSI plugin, and then you can leverage them in Nomad, whether they were ones that worked with Kubernetes or somewhere else as well. Something that's great about this is they're aware of, the Nomad's aware of the CSI managed volumes during the scheduling process, allowing it to schedule your workloads based on the availability of volumes on a specific client. And unlike our previous host volume feature, the volumes can be added and removed from a Nomad cluster without having to change the client configuration as well. So you'd want to use this if you're looking for stateful storage, such as databases, maybe different types of queues where it's important to keep the state and you don't want like your container going down and then losing data. And it lets you use different clouds and different providers. So we could be running on like GCP's disks. We could run on Azure. We could run, well, we will be running on AWS block storage for my demo coming up. And yeah, I think that's all I have for slides. So we'll just go straight into the demo now. Before we got started with this demo, what I did was I terraformed up my environment. So I thought I'd start in the end of the HashiStack code. What we added was the permissions for our existing instance role, which will let it mount the new volume, will mount the volume that we've created down here, but it won't actually let our instance create new volumes on its own, which is pretty important. And we have this output down here, which we use to register the volume itself. So I've outputted that into this volume.hcl file. And I believe we're good to get started now. So there's two different types of plugins that you can use. There's the controllers, or there's the node ones. For the EBS one, we have to use both. So we'll, oh yeah, I guess. I also have these, oh no, Zoom's in the way. Get out of here. So I also have those configurations here in my demo folder to be able to run these jobs. So this is just the Nomad file job configurations. So I'll start my first one. We can see it coming up on the left. And I'm putting up my second one now. Coming here, we can see that there's no volumes already set up. Like I mentioned that this was a fresh install. Just waiting for this to come in. It's there. If I want to check the status, what I can do is run this command to get a better view. As you can see, we have our controllers are up, they're healthy, we expect to have one. And then we can see the controller and the node are both running as task groups. To be able to use this volume, I'm going to need to do a Nomad volume register. So that's just this file that we outputted from Terraform again. Let's just see. Okay, perfect. It is here. That's expected. And then for us to be able to actually show that this works, what I'm going to do is deploy a MySQL job to it. We're going to go into it, check the data, and then we're going to get rid of it and redeploy it and show that the data persisted. So we're going to run my SQL job. It's getting started. Just waiting for this one to come up. Let's check the status over here too. Looks good. When this comes up, we're also going to showcase one of the other features that was released with 0.11, which is remote exec. You can see the button in the UI here already. Looks like it was successful. What we're doing is we're clicking into the task groups and then the allocations, and we're going directly to the lowest level task to be able to exec into it. So we're in the lowest level one. I should be able to exec. So it's opening it. It's running shell. Looks good. So I've currently exec'd into a MySQL Docker container that we're running. We're in the container. We're going to take a look at what's already here. So you can see we have a bike, a baseball, and a chair as our current data. And we're going to insert two things. I'm just gonna run this one more time to show that that did actually go through. We've added this. I'm gonna exit out of remote exec. Oh, that's nice, goodbye. So we're coming out of here, coming back up to here, just to watch how this is gonna work out. We're now going to do a Nomad stop and purge of the MySQL server, which should completely remove the job. So if you just stop it, you see the dead state when you're in the overview. And using this, it should be completely purging it out. Last time I wasn't patient enough while I waited for it though. So we're trying to be a little bit more patient this time around. Going to verify the status that it is not there. This is expected. We've just purged it, so we shouldn't actually be able to see it. And I'm going to run the job again to do another deploy. And what we're hoping to see here is I've redeployed this. We should be able to exec back into this container and see the changes that I made last time because the volume's still mounted through to it. Trying to move this off the screen. Okay, looks like we're all good to go. Just clicking back in again. This seems like I didn't click far enough, but we'll see. Okay, and so we have the extra items that I added previously before doing the redeploy. I'm not actually sure. I feel like that was a lot shorter than the time I had it allocated. Are we good to continue or?
Yeah, you still have time to continue.
Oh, that's like the end of the demo that I prepared. So
Okay, so then we can head on to Q&A, I guess.
Perfect.
All right. Can stop
I'll
sharing.
stop sharing. Yeah.
Then let me put that one back on. Just answering questions. Okay, so I know Ed has collected a lot of questions for us to ask. I try to answer as many as possible already in chat, but I can go through them just so everybody has some visibility on those as well. So let me actually just go through the answers that I actually gave. So some people asked if there's a GitHub project with this code. I'm assuming you're meaning the demo that I gave, and yes, there is definitely. I've actually linked it in the answer, but I can put it in the chat again so everybody can read that. Just give me 1 second. There we go. So the demo is in that GitHub repo, and you can run through that yourself. The only dependency is basically Docker and a tool called Shipyard, which will manage the stack for you. And I'll update the README with the steps that you can actually run through. But it's basically as simple as, let me just do this to get rid of everything. So with Shipyard destroy, I get rid of the entire stack. And then if I do Shipyard run and then point it at my folder where I have the infrastructure defined, it'll actually spin up the entire thing with the Nomad cluster and console configured for you. So stack, you can see that it starts spinning everything up. In the meantime, let me answer more questions. What am I running under the covers? Okay, so what I'm doing in order to support the pods is actually make use of the new features that were in Nomad 0.10, which is the connect integration. So if we take a look at these jobs, I'm using the new network stanza, and I'm using the mode bridge. So I actually get network namespace tasks. In this case, for the web, since I still want to be able to reach it outside of the service mesh, I've also defined a static port. That's why I could curl to localhost and then still end up at the web application. And I can then define a connect block with my sidecar service, and then that actually defines how I can talk to the other applications. And then the whole pod concept comes from that sidecar service. So Nomad will actually inject that for me. So if we take a look here again, we have web, and then inside web, you can see that I have my sidecar service and web. So that's the way I did that. And that works the same for all the other tasks as well. So what is the difference between group count and group scaling min and max? So the scaling stanza is used by the autoscaler to actually control the scaling from the outside. So your group count would then be the initial count of tasks that would be started up, or the group count, obviously. And then the scaling min and max is the minimum that it could scale down to and the maximum that it could scale up to, depending on the policy that you've defined. So, then I had a discussion with DJ Enriquez about the local bind port, where he was wondering if the local bind port actually kills bin packing. And because I'm actually using the network namespacing, I can actually run all of those on the same machine. So as you can see here, I've defined a local bind port of 9091. Normally, if I wasn't using the network namespacing, that would be a problem, because all these applications would want to be scheduled on the same machine, and that wouldn't work. But as you can see in this demo, I actually only have one node, and they all run together just fine, even though most of them have the same ports defined. And that's because they're actually network namespaced, and then all the connecting actually happens under the hood by Nomad itself by manipulating IP tables. So that's a nice way to do that. When I say inject, does that mean it really starts a separate process? Yes, so it actually does run. If we take a look at Nomad, it actually injects an additional task into your allocation. So here you can see that it started the Envoy sidecar proxy. So it's running an actual, like a very tiny proxy, like it would with any other service mesh, next to my task. So this is my task. And then next to that is an injected task that Nomad actually put there. Okay, then a question about grace period with the autoscaler. So if you take a look at the README of the autoscaler right now, it'll say that unfortunately, right now, there's some known issues and limitation. So there are no scaling cooldowns, or there's no grace period defined right now, but that's all coming. So the idea is that you would have a grace period, for instance, when your task comes up. So it might spike in resources for a second and then go down again, that you would want a grace period for that, so you don't immediately scale up and then have to scale down again. Or say, for instance, your metrics are a bit volatile, like mine were in the demo, where it's very spiky. Like if we take a look at, oh, I destroyed the stack. Let's go back to that. No, Google, never. If we go back here, obviously, since I destroyed the stack, we're not going to have any metrics, but it was pretty bouncy with the number of connections. You might want to even that out and say, like, okay, if I've scaled within the last 30 seconds, don't do anything. So yeah, definitely that's going to be implemented. Then Let's see, what does the autoscaler do? So the question was, does it start new instances on the same machine, or can it be different machine, or can this be configured? What it actually does is call the scale endpoints on Nomad itself. So it'll communicate with a Nomad client, and you configure that in the configuration of the autoscaler. So this is the Nomad instance I'm talking to, and it'll call the scale endpoints to actually tell Nomad that, hey, I want to scale this task up and down. So let's see. What is the tool used for the flow graph that displays how the services are connected? So that's a little demo application that we like to use to show how things work without having to actually implement difficult applications. So it's called fake service, and we can actually configure it through environment variables. So we can tell it what name, how to respond, what upstream services to call, the protocol. It can do timing variances. It can say like, okay, I want the 99 percentile to be very slow. So you can actually have that in there. I think I actually defined that for one of the services here. So you can actually tell it how to react, and you can even react with errors. I opened up the GitHub repo here. It's made by my colleague Nicholas Jackson, and it's called Fake Service. And there's a bunch of environment variables that you can actually set. So if you want to use that to test out functionality without actually having to implement a very difficult stack, it's a great way to do that. Let's see. Then again, somebody asking about fake service. So that's that one. Oh, there's a lot of questions. Very nice. Okay, so we had the grace period again. A good question. Can I scale on Nomad metrics? So you actually can. So in this case, we've defined an APM of Prometheus, but we can also scale on Nomad internal metrics. In the documentation, we've actually specified what you can scale on. So if you define the Nomad APM, you can just define source Nomad, and you can have either the metrics of CPU and memory, and then you can append them by average, min, max, or sum. So it's fairly simple, but it works quite well. So you can have the average CPU, for instance, being above 1.0. Then I could tell the target plugin to scale up or down depending on that. So say, for instance, there is no usage at all on the entire cluster. Say, for instance, the average CPU is 0. You could scale down to 0 if you wanted to. So yes, definitely that is possible. Let's see. Ed, could you maybe mark the ones that I've answered? It's hard to keep track. So actually the question, if a pre-start hook has an exit code of not 0, does the job fail? So I will actually test that when Jacquie starts heading on to the CSI plugins. I will test that out in the background and then get back to you on that one. And we are actually at the CSI questions. So Jacquie, you want to take over those?
I can do my best.
Okay.
Let's see. Okay, so I see the question about how to add NetApp Trident or Dell EMC CSI plugins. This is a good question. We have a list of, well, actually, there's a list that we can reference that has a bunch of plugins that were already built by third parties. And because we're already interfacing with the actual CSI, like industry standard level of it, we should be able to just use the plugins if needed. I haven't actually tried a different one yet. Let's see. All right, I'm just looking one of these up really quick to see if I can find some more info to help here. It looks like you should be able to more or less port over the existing CSI plugin for it and be able to rewrite it with the group and tasks and like Nomad centric things. That's my best answer. I'd be happy to look into it more after this webinar and see if I can come up with a better answer that actually shows how to do that. Let's see, what else is here? Okay, about ephemeral disks being good for small storage requirements and advice for largest feasible. So my understanding of it is that the ephemeral disks, they live locally and that you can't really run larger amounts of data on it, and that if you were to lose the machine, you lose all of the data as well. So I think it's just like it's advised not to do it. I pulled that from a blog post that we've written about Nomad. Let's see, which I can share here, as that's what I was referencing. Where's the Q&A gone? There.
In the meantime, I tested the task, the pre-start hook that exits with something different than 0, and it keeps retrying to start it. And then eventually, because it never becomes healthy and everything stays pending, it dies. So there's the answer to that. Which one were you answering now, Jacquie?
I'm looking at, can one register the volume from within a job definition, or does it have to run as a server client configuration? So I think for the CSI ones, they're possible to run. Let's see. Because one of the nice things about using CSI versus the host volumes and the other ones was that it doesn't have to be configured at the client configuration level. I'm just trying to find my config to see if this clearly shows it so I can actually just show it instead of talking. Yeah, it does. I probably breezed over this a little bit too much. I'm just gonna screen share really quickly to here. So you can just kind of see, and this is in my MySQL job, that it has the volume out here. And when I created it using this. So that's kind of how it knows to tie to that. But it was made in using Terraform in AWS and then connected through the actual job description here.
Hey, Jackie, your screen isn't shared right now in case you were trying to show that to people.
Oh, no. Okay. Here we go. Is it working now?
Yes, it's working now.
Yay. Okay. Sorry. All right. So what happened was we created it using Terraform, and this output connected this volume. It gave us the information that we needed. So this is what I used to register it. But where it's actually getting assigned is in this MySQL job configuration. It's got the volume being mounted right here, if that helps to answer the question. Just scrolling through the other questions here. Erik, I think you know this offhand. I think it's true, but is it possible to run Windows containers with Nomad? Or to have Windows nodes?
Sorry, I was trying to find Zoom in all the windows. It was behind
No
something.
worries.
Yes, you can run Nomad jobs on Windows as well. So you can run Windows executables, or I haven't actually tried running Windows containers myself, but if it can just talk to the Docker daemon, it should work. I'm actually running WSL2. That works. Oh, and I actually do know Shipyard uses Docker on the background, so it should work for Nomad as well.
Okay, perfect.
The only thing is, though, the service mesh features right now won't work directly because Envoy is still being ported to Windows by Microsoft and Pivotal, but they're working hard on that. So hopefully soon all those Connect integrations will work as well. But you could override the sidecar task and like do it yourself with the Connect proxy or something like that. I was in the meantime trying to follow up on the submitting jobs through the UI. Since I've never tried to lock that down, I was trying to ask an engineer for that. So let me check that. In the meantime, let me check if there are any other questions I can answer. Oh, so lots of here doc and some nested here docs. Is that typical? That's just because I didn't want to load any files from the machine, and I just wanted everything to be nested inside the jobs themselves. So it would actually all be self-contained. So for instance, I have a huge here doc or a huge template in my monitoring job for all the Prometheus configuration, and I even embedded the entire dashboard in there. So if you would run it, you would have all of those immediately. But I could also pull these in through the artifact stanza, and then, yeah, that would make the job a lot cleaner. But that would mean that you might not have access to these resources. So that's why I actually put them in the templates themselves, so everything's bunched up together. So definitely does not have to be this way. Let's see, so that was that one. Let me just mark them. Oh, that's deleting them, that works. Autoscaling, is it pluggable with cloud monitoring services like Datadog, Elasticsearch, etc.? So the autoscaler is entirely pluggable. And I believe we're actually working on a Datadog APM integration right now. I believe there was somebody that offered to help building that. So yes, it's definitely possible, but they don't exist right now. So in the initial setup, we've created a Prometheus one, but there's going to be a bunch more for sure. So that was that one. What does the autoscaler do? There, that one. Jacquie, do you know if the Docker named volume one, if that's already working?
Off the top of my head, I'm not sure. Sorry, I was just looking into how to better answer the CSI plugin question that we have.
Okay, that's fine. Like any questions that we don't get to today, we will send out in the email following up this, which will also have a link to the recording of this webinar, if I am right, Ed.
Correct. Yeah, we're going to link to all the resources, and then this Q&A section will also be included in the recording as well.
Okay, cool. Okay, so is there a benefit to running a sidecar per container versus running a sidecar per machine? So in case of the service mesh, it's kind of the default way that things are configured. And it does actually allow you to do load balancing from application to application directly. So there's no central proxy where you have to go through, which can be kind of nice because there's also some L7 features in the service mesh where you can configure retries. So those retries would actually happen from the task itself to the endpoint it's trying to connect to. And one of the other benefits is the applications are actually only talking to local host inside the network namespace. And then from there, everything is MTLS encrypted until the namespace of the other task. So everything is beautifully encapsulated inside these namespaces. Okay, so another one. Does Nomad support task and client autoscaling? So right now, Nomad supports the scaling of the tasks, but since the model is pluggable, there's definitely going to be other modes of scaling as well, where you'll either scale up nodes, or there's even the thought of scaling up the resources of a task, for instance. So definitely, but not yet, sorry.
So another question we had is that CSI is still considered to be beta, and what is the bar for the stable release that has yet to be met, and when is that release expected? So I got an answer, I asked internally, and it's okay, but basically they're looking to include some more robustness to the features and to get some more integrations before it's ready to get shipped out of beta. And then I saw the UI question and I'm trying to find it again.
Okay, so in the meantime, I actually found the answer to the ACL or the UI question. So Charlie says it's subject to the same run permissions as the CLI. So you could actually limit that with ACLs. And Michael thinks that it should now disable the button in the UI. He thinks, but he forgot if we got that in. So otherwise, there's a little spoiler that's probably coming up then. Where's the document? So many good questions. Okay, so let's say I have a job with a group count of 2 and a pre-start hook task and just one host to schedule the jobs. So Nomad would deploy 2 services on one host. Would also the pre-start hook be called twice on that host? So if, let's say, I do some file remove, move, etc., I could get into concurrency problem. That depends. So with the files, normally Nomad basically roots your application. So there's file storage local to the allocation itself. If you do the moving of files there, then that should not matter. If you do, for instance, a raw exec job and you're moving the files there, then, so first of all, yes, the hooks get called for each of those tasks because the group actually gets scheduled on multiple places. So in case of raw exec, and if you're actually manipulating the host file system, then yes, you would have to watch out yourself for those impacts. Can you set multiple scaling policies? I believe you can. And I will actually double check that right now because I was thinking of that before and I didn't double check. In the meantime, if we continue with the CPU usage on the Nomad task in the autoscaling metric, can we scale it down to 0? Then would it scale back up when necessary? So yes, with the target value, you can actually scale to 0, which can be very nice for several use cases. For instance, if you're watching like a worker queue for if there's any tasks available, you could scale up to clean that worker queue and then scale back down to 0. And that could work the same with the CPU usage. Let's see. So I think I did that one at stop cleaning, so I am losing track again. Thanks, Ed. I think that's most of the questions answered, except for the multiple scaling policies. And let me check that right now. So let's see, policy. Okay, checking it out. I don't see why not. Shall I just try it? I guess that's the best way to figure out if it works, right? Autoscale. Let's put another one. Let me share this so we can all see the demo fail live, right? People love that.
It's much more fun to watch than to do.
There we go. Let's get rid of that and I don't know. I'm guessing. Let's put the CPU load on 1.0 or something. And it accepted it, so that's a start. And then if we take a look at the, well, the payments died. Oh yeah, because I had the exit 0 in there. That doesn't matter for this use case. Let's take a look. Okay, so it's totally fine with multiple policies. Now, if I fix the payment service, which I had done in here, or more simply, I can just stack Nomad payments. There we go. That'll probably be faster with getting that back up and running. Okay, cool. So that works. Now I actually need to put some load in this again. So let me start my load tester. I'm just running Hey, by the way, which is a very nice, simple load test tool. So I'm running it for 10 minutes and a concurrency of 35. And I'm just hitting localhost. So CPU usage is now 5. So I would assume that we would get something, but it's not scaling yet. Still happy. Okay. This should cause it to scale. Now I'm wondering if they are conflicting. So let's take a look at the autoscaler and see if we can get some information out of that. I believe it puts it on standard error. Oh, well, yeah, that doesn't help. I didn't configure the Nomad APM in the autoscaler. I guess we could do that. I believe it works like this. Now we're going to find out if that works. Stack, autoscaler. We're really going off the cuff now. Okay. There we go, pending. Okay, apparently that's not the way to configure it. Oh, I don't have that plugin. So I'll have to check that out later and then send that in the email, Ed. So with that, I guess that's the ending of this webinar. Thank you all for joining. And we will send out the answers to the questions and the link to the live stream.